Chapter 6, Section 1, Factors that are opposites. Um, See a lot of issues come around negatives, and we can always factor out negative ones if we want to change the value, the signs of any terms in a sense. And this is what they're going to look at this as a strategy to work on simplifying expressions. So they want us to consider this expression here, x minus 4 over 8 minus 2x. And we could factor that. First you look for common factors. There's nothing in the numerator. But there is a 2 that's a common factor in here. And we get 2 times 4 minus x. At first glance, the numerator and denominator do not appear to have any common factors. They're not exactly the same. But if we think about or look at this, x minus 4 and 4 minus x are opposites or additive inverses of each other. Which is a good thing to remember, this additive inverses. In other words, if I added them together, I'd get 0. Thus, we can find a common factor by factoring out a negative 1 in either expression. So let's look at the process of doing this. And this is always a nice tool. Last chapter we talked about sometimes it makes it easier to have that first term be positive. We could always factor out a negative 1, but don't forget to put that back into our factoring. Well, let's look at how they do example 6 here. So to simplify this one, we look to factor, we go in here, hopefully you recognize, hey, 4 minus x is the opposite of x minus 4. In other words, the term x is positive here and the term x is negative here. 4 is positive here, negative here. They are opposite terms. Sign terms in a sense. Well, I can factor out of this one in what they do is a 4 minus x, which seems kind of logical because we're used to the variable or the polynomials being in order, in descending order as far as degree of the each term, right? So, and that's what they do. And they say, well, I can rewrite 4 minus x as negative 1 times x minus 4. Think about this. This multiplied together will give you this. So this is another way to write this by changing the signs of each term by factoring out a negative 1. So now I can look at this and I really have negative 2 when I have 2 times negative 1 is negative 2. But I have x minus 4 over negative 2 times the quantity x minus 4. Hey, here's our common factors. The other thing that we seem to have a lot of errors with is, remember 1 is always a factor of anything. So I could say x minus 4 is the same as 1 times x minus 4. And I see this problem when I see this, well, you get stuck because you don't know what number to put there. That's what I do. Just like I say, rewriting this by putting negative 1 in front, well, I could rewrite x minus 4 as 1 times the quantity x minus 4. And then I have that 1 to be left behind after I break this fraction out into this part that's equal to 1. And don't forget your negatives, okay? So I end up with a negative 1/2. And this is where they go through that check process again. As a partial check, note that for each choice of x other than 4, because why do they say not 4? Well, 4 would be restricted because that would make the denominator equal to 0. Just like the first part of this section we're talking about. Look out for those restricted values. And so we'd go through this and they say, well, let's try if x is 5 and see what happened. Here's the original, and we got when we simplified this, we got negative 1/2. Well, let's see what we get here. 5 minus 4 is 1. 8 minus 2 times 5, order of operations, I get 8 minus 10, which is 1 over negative 2. So it does work. Now quickly look at this one right here on the side. X minus 2 over 2 minus x. If you understand this and understand the process, you should very simply be able to say this is equal to negative 1. And how I'd get there is say, well, this is negative 1 if I factor out negative 1 from this one, I get negative 1 times x minus 2. So then I end up with 1 over negative 1 times 1 with those factors. So hopefully you get that good at this, working with the negatives. This is a nice thing to think about. You're going to have some homework that does some of this, but that's a very important part of finding ways to simplify these rational expressions.